So the next or the last part of this particular chapter, chemical bonding, is coordinate covalent bond or dative bond or semi-polar bond, we can say that. Now let me tell you, coordinate covalent bond. So actually this, you will find it out that this molecule, coordinate covalent bond, you will find it out this molecule has got the properties of both ionic as well as covalent. Because when the compound is being formed, first sharing of electron takes place, then a transfer of lone pair of electron takes place from the central atom. So what I said, first sharing, so covalent, and then transfer of lone pair of electron takes place from the central atom to the surrounding atom. So it is more or less ionic, I can say that, because in ionic also transfer of electron takes place, but in ionic not a lone pair, a single electron takes place. Alright, that's the difference. So what is then coordinate covalent bond? How can we define it? Coordinate covalent bond is nothing but a bond which is being formed from that is the central atom to that of the surrounding atom, in which the lone pair of electrons is transferred from the central atom to that of the surrounding atom. Okay, again I repeat, coordinate covalent bond, it's a bond formed when the lone pair of electrons gets transferred from the central atom to that of the surrounding atom, which is having deficiency of electrons. Now here I have used a word, lone pair of electron. Now you can see my definition in my notes. You can get my definition in the notes. You can get it in the notes, the definition, you will see it there. Now you just understand it, this is what I am saying. Now lone pair of electron, what does it mean by this particular word? So after the central atom has attained an octet structure, remember that in a particular molecule we are having a particular atom which is said to be as a central atom. So once the central atom attains the octet structure, that means its outermost shell is fully filled, then what happens is there are pair of electrons which does not participate in bond formation. There might be some pair of electrons which is not participating in bond formation. That pair of electrons is known as lone pair of electrons. You can say that. Once again I repeat. So when the covalent bond formation takes place, you will find it out that you will get a central atom and it will be surrounded by that number of atoms. So in central atom you will find that, or you may find, that is not in all the molecules. Let me say you, the one which undergoes coordinate covalent, for them I am talking. So you will find that there are one or two pair of electrons, you will find it out, that it does not participate in bond formation. After the central atom has attained the octet structure, it does not participate in bond formation. So that is called as lone pair of electron. Here I am using the word central atom. Remember it, central atom. It is not for any other atom. It is only for central atom, we can say that. Alright, because when you draw the structure, you will find that many other atoms will have what you can say pair of electron which does not participate in bond formation. So that is not called as a lone pair. Only the central atom. I will draw it and I will show it to you which is the central atom. So first you understand it. So coordinate bond is nothing but, again I repeat, it is a bond formation takes place when a lone pair of electrons get transferred from a particular atom. Which atom? That is from the central atom to the surrounding atom. Alright, it gets transferred. Alright, then the bond formation which takes place, that is said to be as coordinate bond or dative bond or semi-polar bond, we can say that. Okay, now we will see the formation of this coordinate bond. We will see it. We'll understand that how it is being formed. We'll take an example and we'll understand it. So we will take the example of hydronium, that is ion. Hydronium ion. Hydronium means H3O plus. Now first of all we will draw for the water molecule. Now hydronium ion, how it is being formed, you see it here. H2O, now oxygen is having two lone pair. I will show you how it is. It gives one lone pair to the H plus ion. Why? Because H plus means what? What do you mean by H plus? H is having one electron in the outermost shell. It loses that electron also and it forms a proton or a cation. We can say that is H plus ion. So when this oxygen gives a lone pair of electrons to this H plus ion. Now why H plus ion? Because this H plus ion is having deficiency. It requires how many electrons to be stable? 2. So hence this electron is given to H plus ion and hence what it forms? It forms H3O plus. Remember it. That is oxygen is having two lone pair. Now how oxygen is having two lone pair? See it here. So we will see the formation of the water molecule. So we have seen it already, the formation of the water molecule. If you have forgotten it, once again I will draw it, then I will show it to you. Otherwise, oxygen is having 6 electrons in the outermost shell. Hydrogen is having one electron each. Alright, so I have done it cross to make you understand it. So here you can see hydrogen becomes duplet, oxygen becomes octet. Count it 1, 2, 3, 4, 5, 6, 7, 8. So after oxygen becomes octet, see it here, oxygen is the central atom here. Oxygen becomes octet. We are having two pair of electrons which does not participate in bond formation. This is known as lone pair. This is said to be as two pair of electron. You can see that it does not participate in bond formation. After it has attained the octet structure, count you can see 1, 2, 3, 4, 5, 6, 7, 8. It has attained the octet structure. Then we are having that is two pair of electrons left out, which does not participate in bond formation. This is known as lone pair. I think it's clear, and we are talking about the central atom only, not any other atoms. We can say that, not any other atoms. So now what will happen? This lone pair, so I've already showed you that it will be giving to the H plus ion, and hence what is going to form? It is going to form, that is H3O plus, one lone pair remains and it is positively charged. So in this way, this particular ion is known as hydronium ion. We can say that. Similarly, we can show the formation of the ammonium ion also. Now that is a homework for you that I am giving you as a homework, that you draw in your home the formation of the ammonium ion. How do you draw it? I am saying you, ammonia when it reacts with H plus ion, it forms ammonium ion. Draw this particular one and you show it to me. You send it to me, rather the pic. We can say that. So this particular compound is said to be as nothing but coordination compound. We can say that. This particular one, or the bond formation which takes place. So first you can see that is sharing is taking place. Then a lone pair of electrons is getting transferred to the surrounding atom which is having deficiency. So hence this is said to be as a coordinate bond. So here these two are covalent, and here I'll put an arrow. So this arrow represents a coordinate bond. So see, I put an arrow here which represents a coordinate bond, and it is positively charged. I put a positive sign here. So this is how a coordinate bond formation takes place, you can say. Thank you very much.